Hey everybody, welcome back to EE368, Signals and Systems Laboratory at Cal Poly. Today I'm going to be showing you how you can take input data from your oscilloscope and put it into Matlab. So I'm here in the Systems Laboratory 20-113 in the E building, and for this demonstration we'll be using this Agilent 33120A function generator. We're going to be outputting a sinusoidal voltage source at about 1 kilohertz with an amplitude of 1 volt peak to peak. And we're going to be running a BNC cable into the oscilloscope. And we are going to want to read just channel 1 for now. So we can turn that off. All right, now that we have our setup, we can go ahead and open up the PC. I'm here in 20-113, the systems laboratory. We can go one of the bench PCs. We can go ahead and open up Keysight bench view. Let that load up. So down here, you should see the oscilloscope connected to the PC. If it's not showing up, you're likely missing a USB cable. We can go ahead and double click this. And what this will bring up is a sampled version of what is being output on your oscilloscope currently. So we can go ahead and export this to a CSV file. I'm going to go ahead and call this demo 1, and I'm going to not include the number here. So we export that, and here we have demo 1. From here, we can go ahead and press Shift, right-click to copy this file as a path. And then you can open up Matlab, and I'll show you guys how we can open it up in Matlab, read it in as a table, and then play around with values. So here I have this data transfer.m file. The first thing we're going to want to do is read table, and then we can just go ahead and click Control-V to paste the file as a path. And then let's just run this and save this as our input data. So input equal to read table. So after running this in the workspace, we can see that we have this input variable. It's actually a table with columns sample number, time in seconds, and the X1 channel 1 voltage. And variable 4, which is something that would appear if we have channel 2 connected. So here we can actually go ahead and type plot input dot, let me double check here, the naming convention. So time underscore s underscore, so time underscore s underscore. So this is going to be case sensitive, make sure to remember that. And then x1 underscore volt underscore, so x1 underscore volt underscore. And I'll go ahead and I will call this figure 1. We can plot this, and then we'll have a title, voltage over time versus time, and then we can put in a X label. It's going to be time in seconds, and a Y label. It's going to be VN and volt. Sure. So we can go ahead and run this again, and we will see a really awesome plot, hopefully. Oh, like something. Oh, I forgot to, so when you reference this X1 voltage, you have to also reference the data, the variable that we stored it in. So let's try that again. And there we go. So we have voltage versus time. So here we have time in seconds and our VN. And then we can also use this to, obviously, if we connect the channel 2 to the output of your circuit, we can look at the transfer function directly from the benchtop equipment, which is super awesome. All right, I'll see you guys in lab.